So this is a session on Kubernetes. Before I start the session, I want to acknowledge MS Learn because a lot of the material is inspired from it. Now before we jump into Kubernetes, we must understand these concepts. What is container management? Container management is a process of organizing, adding, removing or updating a significant number of containers. A container orchestrator is a subsystem that automatically deploys and manages containerized apps. What is Kubernetes? It is a portable, extensible, open source platform for managing and orchestrating containerized workloads. It abstracts away complex container management tasks and provides with declarative configuration to orchestrate containers in different computing environments. The benefits of Kubernetes: self-healing of containers that would be like restarting containers that fail or replacing containers, scaling deployed container count up or down dynamically based on demand, automating rolling updates and rollbacks of containers, managing storage, managing network traffic, storing and managing sensitive information. So the most important thing about Kubernetes is a cluster. It has two things. One is a node and another is the control plane. The computers in a cluster that run the tasks are called the nodes. The computers that run the scheduling software are called the controller plane. The cluster is composed of the control plane and the nodes. The control plane has a Kube-api server, a controller, a scheduler and etcd. We will see them in details. And a node contains a kubelet, Kube-proxy and the container runtime. Both the controller planes and the node instances can be physical devices, virtual machines or instances in the cloud. The default OS in Kubernetes is Linux with the default support for Linux based workloads. The Kubernetes control plane in a Kubernetes cluster runs a collection of services that manage orchestration functionality in Kubernetes. What is an API server? It is the front end to the control plane in our Kubernetes cluster. All the communication between the components in Kubernetes is done through this API. We might use a number of times a command line app called kubectl. The kubectl will issue commands, will issue YML files, and that interacts with the Kube-api server. Each node communicates with the control plane via the API server to inform it about state changes on the node. What is etcd? It is a high availability, distributed and reliable key value store called etcd, and this stores the current state and the desired state of all objects within the cluster. What is a scheduler? It is a component that is responsible for assignment of workloads across the nodes. What is a controller? The controller manager launches and monitors the controllers configured for a cluster through the API server. The Kubernetes uses controllers to track the state of the objects in the cluster. Each controller runs in a non-terminating loop while watching and responding to events in the cluster. There are controllers to monitor nodes, containers, and endpoints. What is a kubelet? Now we go on to the node and we are seeing the kubelet. The kubelet is the agent that runs on each node in the cluster and monitors work requests from the API server. It makes sure that the requested unit of work is running and healthy. Kubelet monitors the nodes and makes sure the container scheduled on each node run as expected. The kubelet manages only containers created by Kubernetes. It is not responsible for rescheduling work to run on another nodes if the current node can't run the work. The Kube-proxy is responsible for local cluster networking and runs on each node. It ensures that each node has an unique IP address. It also implements rules to handle routing and load balancing of traffic by using IP tables and IPVS. The container runtime is the underlying software that runs containers on a Kubernetes cluster. The runtime is responsible for fetching, starting, and stopping container images. Kubernetes supports several container runtimes, including but not limited to Docker, RKT, CRIO, Containerd, and FracT. What is a pod? The pod represents a single instance of an app running in Kubernetes. The workloads that we run on Kubernetes are containerized apps. Unlike in a Docker environment, we can't run containers directly on Kubernetes. We package the container into a Kubernetes object called a pod. The pod is the smallest object that we can create in Kubernetes. A single pod can hold a group or one or more containers. However, a pod typically doesn't contain multiples of the same app. The pod includes information about the shared storage and the network configuration and the specification about how to run its packaged containers. We use the pod templates to define the information about the pods that run in the cluster. Pod templates are YAML coded files that we reuse and include in other objects to manage pod deployments. What is a deployment? A deployment creates a management object which enables to deploy and manage updates for pods in a cluster. For example, we have all these nodes which are of version 1. Right, if we decide to update our app manually, we can remove all pods and then launch new pods running version 2 of our app. With this strategy, our app will experience downtime. Instead, we will execute a rolling update whereby we can launch pods with a new version of our app before we remove the older app version pods. The rolling updates will launch one pod at a time instead of taking down all the other pods at once. Deployments honored the number of replicas configured in the section that describes information about the replica sets. It will maintain the number of pods specified in the replica set as it replaces old pods with new pods. So at any one point of time, you will have version 1 and version 2, but ultimately it will become version 2. So now we come to the concept of a service. The service allows us to communicate with pods very easily. Suppose one pod has gone down, but it doesn't matter. If you are interacting with the service, it will route it to the other healthy pod while the other pod is being brought back up. So Kubernetes service is a Kubernetes object that provides stable networking for pods. It enables communication between nodes, pods, and users of the app, both internal and external to the cluster. What is the cluster IP? When created, each service is assigned a unique IP address called the cluster IP. The address is tied to the lifespan of the service and will not change while the service is alive. The address assigned to a service that makes a service available to a set of services inside the cluster. Note the word inside the cluster. While a NodePort is the one where you can access the NodePort service outside the cluster by requesting node IP :NodePort. It exposes the service on each node's IP at a static port, the NodePort. The cluster IP service to which the NodePort service routes is automatically created. Another part is the LoadBalancer, which exposes the service externally using the cloud provider's cloud LoadBalancer. NodePort and cluster IP services to which the external balancer routes are automatically created. So this ends our lecture on Kubernetes. Hope you liked it. Thank you. Bye.